Hi, in this video I have the lithium powered UPS. It's the 1200 VA or the 720 watt version. Right, in this video I'm going to go through the unit. I'm going to show how it works. I'm also going to go through the specifications and test the unit. So in this case it says the maximum output is 720 watts. It says that the output voltage is anything between 200 and 255 volts AC. I will measure that. It says the output frequency is 50 hertz. I will also test that. The battery rating is 144 watt hour and it's a lithium iron phosphate, so that's looking good. The backup time has a claim of 200 watts at about 33 minutes. I will test that. It also says that the noise level is below 45 decibels. I will also test that. Right on the box it says it's got a built-in USB charger. I will demonstrate that. It says that it's got an automatic voltage regulator. I will also test that. It says it's got a built-in circuit breaker. I'll test that by initiating a short circuit and see what happens. Now the reason why I like the unit is because it says it's got a lithium ion battery, which is far superior to a lead acid battery, because I'm sure those who have bought UPSs in the past have noticed that if it has a lead acid battery, the lifespan is very poor. The lead acid batteries are not designed to be charge, discharge, etc. But while these lithium ion and particularly the lithium phosphate batteries have a much longer lifespan. So I have the unit and I'm going to show you the setup and then I will do the tests. Now the first thing that I notice is the unit is quite small, just about 8.5 centimeters wide, and the length, including the raised section for the plug outlet and the wire, is about 30.5 centimeters. Right, and the height off the ground is just below 14 centimeters. So the unit is pretty small, and while it is small, it is quite heavy for its size at 4.5 kilograms. Now that weight is not a bad thing. The heavier the UPS, actually the better, because there should be quite a hefty transformer inside. I will open it shortly and show you the transformer. And this being lithium, the lithium ion batteries are lighter than the equivalent lead acid batteries. So the fact that it is quite heavy, that's actually a good sign, because that means there's probably a nice bank of lithium ion batteries as well as a transformer, which I will open and show you shortly. Right, I'm going to start at the back. There is the breaker, the circuit breaker, 250 volts, 6 amps. There's the input. Notice that it's hardwired. So it's hardwired. Here is the plug, which gets plugged into your mains. There is the single output for your appliance. Now I'm going to plug it in so that I can show you the front display. So I'm just going to plug in a load so long. Right, on the front I have the power button, then I have this USB port, I have a bar graph indicating the battery status, and then I have a 3-digit LCD over here. Power it on, I press and hold this button. It's quite a deep press and the unit is now turned on. Now the display shows a sequence of information. For example, right now it is saying 222V, so 222 volts, and it says in. So that's what's coming into the unit from my utility, from the console. Now if I press the button, the power button there, it shows me the output voltage. So this is what's leaving the UPS at the moment. It's the same voltage. And the reason being is that currently the mains is on, which means that the UPS is in a bypass mode. It means that the output is fed directly from the input, and therefore the UPS is in a bypass mode. So the input and the output are matched. Now if I press this again, it shows me the percentage loading. So that gives me an idea of what I've connected. I've connected an appliance, and the appliance is currently asking for 38% of the rated capacity of the unit. If I press it again, it says 001. The 001 indicates the load level. It goes from 1 to 2 to 3 depending on how much you load it, 3 being higher, 1 being lower. Right, if I press the button again, it toggles back to the start of the menu, and there we see the input voltage. Right, so I'm going to unplug the UPS. Right, unplug now. Notice that the display immediately changed from in to out. So now that is the output voltage. It's 216 volts. And if I press the button again, we can see that the loading is rated at 41%. Notice the battery bar graph dropped quite rapidly to like halfway, and it was fully charged. Right, and if I press it again, we should see, yes, see there it says 002, telling me that the mains is unplugged. So now it is in the backup mode. It's running only from the battery. I can hear the unit is running from the battery. It's got a bit of a buzzing sound, not too bad, and I will measure it for you. And I want to just go through the menu, and there you can see input voltage, it's blanked out, meaning there's no input voltage. Now when I plug in the mains is plugged in, and there we can see back to the mains voltage 222, and the output and input on our match. All right, so now I'm just going to lastly just show you this USB connector. I'm going to use this to charge a cell phone. Right, it's plugged in on the front there. We can see the voltage is about 5 volts, which is correct. And the specification says that it can go up to 2 amps. Right, so there I've plugged in my phone and we can see still 5 volts. And let's have a look at the amperage. 1.2, 1.4, 1.4, and the phone is not in the fast charging mode, but that is because the voltage is 5 volt. Yes, it is suitable to charge a phone, but keeping in mind that for the very fast charge, we need a higher voltage. Right, now in order to test the unit, I have my load here. These are 100 watt globes. Now according to the specification, it says that it can handle 200 watts for 33 minutes. So that's what I'm going to test now. I'm also going to take a measurement of the noise. So that means I only need to run 2 globes because they're 100 watts each. Right, so I'm going to plug this in. The globes are on. At the moment, the mains is connected. So I'm going to disconnect the mains and start the timer. Right, I've just started the timer. The mains has been disconnected. Right, just to confirm the power output, this is the current. It is 0.856 amps, while the RMS voltage is around 224.3, which gives me a power output of 192 watts. The load is tungsten globes, so they are resistive. So I'm going to take the power factor as 1. So I'm loading it close to 200 watts. Right, the unit is currently running off the battery. The mains is disconnected. The output voltage, according to the display here, says 220 volts or 221. If I quickly look at the percentage loading, it says it's 22% of maximum capacity. The battery is currently rated at still full, and let's look at what the meter says. Okay, according to the multimeter, it's 222.9 volts, so it is pretty close. I don't have a problem with that. Yes, it is exactly 50 hertz. The output is not a sine wave. It doesn't claim to have a sine wave. This is quite common on the offline UPSs. An offline UPS is a UPS that comes online or runs from batteries only when the mains has been disconnected. So the purpose of this UPS is not to clean the power. It's literally there just to give you backup while the mains is offline. So just having a look at that view, you can see that it's a square wave, and that is the nature of these type of UPSs. Some devices will not tolerate those type of waveforms, but most modern computers and laptop chargers will be able to handle that type of waveform. What's more important at this point is to have a look at the duty cycle. What the duty cycle is telling us is the top part of the waveform the same as the bottom? And that is what's very important. And in this case, it's exactly 50%, which means that the square wave on the top and the square wave on the bottom are close. They are matched. That's very important. And in this case, it is correct. Right, just having a look at the pulse width, we can see that it's got a 10 millisecond pulse width. Right, an important test while we're doing this discharge test is to just see what happens when we plug in the mains now and then see how quick does it take the unit to get back to mains, and also is there any noise that comes through, are there any surges? So I'm going to quickly test that, and then what I'm going to do is remove the mains again and see what happens when we remove the mains. So we want to make sure that there are no surges coming through, although with these domestic type UPSs they tend to have some noise coming through, but anyway, let's just test that. Right, it's currently just connected to a 200 watt load. It's pretty close to 200 watts, and this is a tungsten globe, so the power factor is pretty much unity. And let's now connect the mains and then see what happens to the waveform. Right, so you can see me in the background there. I'm plugging in the mains, and yeah, there we go. So it's back to sine wave, but now let's see what happens when we unplug. Right, so I've set the meter to glitch capture to see if there's any surge that comes through here. All right, so that's what it looks like when we unplug it from mains to backup power. So you can see that it is not too bad. I didn't see any surge coming through there. Let's try again. Okay, again, looks quite good. There was the original sine wave. It was the utility sine wave, and then it goes into backup mode. Let's try one more time. Response was quite decent. Look, it was only 3 times I tested it, but I did not see a surge. It's not a perfect transition because it's going from sine wave to square wave, but for this type of UPS, that is totally acceptable. Right, I did manage to catch one more, and there's a little bit of ringing there. The next quick test is to see what happens when we plug in the mains. Is there quite a disturbance to the load or not? So I'm going to plug it in now. Then I unplug there. You can see it dimmed a little bit, and I plug it in. And now it's on mains, and I unplug it, And you can see there's a bit of a disturbance there to the load. That is quite common on these types of UPSs. Yeah, there we can definitely see there is some dimming there. So there's a little bit of a dead time there. So what does the unit sound like? Well, there's a bit of a hum coming from the unit. It's like a buzzing sound. I'll play it for you. And the noise does get a bit louder when I increase the load. So if I increase the load, we are getting more noise. Right, let's just check in on the unit. We can see that the bar graph has dropped to halfway. And according to our timer, we're at 25 minutes. It says that it should be able to provide you with 200 watts for about 33 minutes. And in this case, we're at 25 minutes. So let's wait another 8 minutes. Right, so the unit didn't quite get to the 33 minutes. It was pretty close and it was a good attempt. There is a bit of heat coming off the unit, nothing concerning. And I'll just take a measurement quickly. And there we can see just below 40 degrees and close to 41 degrees on the other side. Now, according to the manual, you must leave at least 10 centimeters open on either side of the unit. And that is because there are these vents and air does need to flow in and out here. The unit doesn't have a fan, which is not good, but then it's nice for the user because there isn't that fan noise going and there's no buzzer. So that's also a nice feature. A lot of people complain about when the power goes off, then the UPS is making a deet, deet, and it's quite annoying, whereas this unit does not do that. It just goes into the backup mode and it will just provide you with that backup power without making a noise. Right, I decided to run this backup test again, because I was fiddling with the unit, switching it on and off during the last test. So let's run it again. And the test has started. We can see that the voltage is quite stable. There it's 219 volts. Right, so the unit does give you the 30 minutes at almost 200 watts. So it's not quite what the specification says, but it's pretty close. It's within 90%. Right, so what I always like to do is open things up and see what we've got inside. So there are 2 screws here, 2 here, and then 1 just over there. Now, if you open it up, you are going to void your warranty. I'm just opening it up to show you what you'll be buying. All right, so there's output transformer. That's what the buzzing is. And here are the lithium ion batteries. You can see there's a nice bank of lithium ion batteries. There are the relays which switch on and off depending on the mains or whether it's on backup power. There's a top view and there's the side view. There's the output stage, the FETs, which are going to convert the DC into a pulse DC, which in other words will be an AC. Right, now there is the circuit breaker for overcurrent protection. One thing I was interested to determine is whether the circuit breaker is for the input from the mains or whether it's for the output from the battery, or whether it's an output circuit breaker. But in this case, the way it's wired, it comes from the mains to the one side of the circuit breaker to the other side. This circuit breaker is here to stop you from overloading the unit while it is on mains. Right, so the maximum power output on the specification list says 720 watts. Right, so I have 6 of these 100 watt tungsten globes. And I'm going to see if the unit can switch on the 600 watts and just see if the unit is stable. So this is close to 600 watts. And what I'm going to do now is plug it in. Right, so I currently have the mains disconnected and I'm going to plug in just the load. This means that the full 600 watts should come from the battery. Right, so the unit is powering up the 600 watt load. And now I'm going to go to mains. Right, so now it's on mains and I'm going to go back to battery power. Right, so there it's on battery power and back to mains. Right, and I have a 2 kilowatt iron. I'd like to see if the circuit breaker operates because the power required for this iron is way more than the specification of the UPS. However, the UPS has a circuit breaker. So I want to see if the UPS's circuit breaker will operate under an overloaded condition. Now the UPS is currently plugged in. So it's on mains. Right, so the iron immediately turned off. And interestingly, the UPS automatically turned itself off. I'm going to turn it back on. Right, it is on, and I'm going to plug in the iron once more. Right, the UPS went off. Right, so the UPS automatically went off once I plugged in the iron. I've now plugged in the iron again, and I'm going to try and switch it on. And it says overload. It will not allow me to switch on a load bigger than the UPS can handle. Now what I'm going to do is put it on, unplug it, so it's going to run off battery. And now I'm going to plug in that same iron while it's on battery mode or backup mode. Right, and straight away it says overload, and the unit has now turned off. Right, just to make sure everything still works, I have my globes there, 600 watts. I've plugged it into the unit. The UPS is currently disconnected from mains, meaning that if I switch it on now, it should run off battery alone. There it says overload, even though it's not an overload. Let's try again. Right, so it's not switching on my 600 watts. I'm going to reduce the wattage. I'm going to take it down to 400 watts, and I'm going to try to switch it on again. Yes, the lights have come on. So it didn't like it that I switched it onto 600 watts. I'm going to now increase the load. Yes, it allows it. And I'm going to take it to about 600 watts. Yes, it allows it. So what that means is it's always best to increase the load slowly instead of switching on the UPS directly onto the load. So that's not necessarily a surprising finding. So that's an instruction for many UPSs and even generators. They say increase the load slowly. So that means plug in your laptop, maybe plug in your monitor, but don't plug in everything at the same time. Build it up. So you build it up over time. So that is understandable. If you do put quite a high load on the unit, you might get this display. I'm not entirely sure what this means. I think it refers to the temperature. I think it's saying that the battery temperature is high because it turns off shortly afterwards, even though there is still battery capacity. Because if I switch it back on to just a 200 watt load, there's still capacity to run my lower wattage load. I think what's happening is this is a thermal cutoff. So if you do overload it, it seems like it will protect itself and it will cut out if it gets too hot. Right, and just feeling underneath, yes, it does get pretty hot. So I think that's what's happened. It's over temperature protection, and when I feel here with my finger, it is pretty hot. Yeah, and I measure underneath, it definitely has gotten hotter, almost 47 degrees. So that I believe is a thermal cutout. Right, now to measure the sound pressure level or the noise of the unit, I'm going to use an SPL meter, and I'm going to measure it at 1 meter from the unit. Right, so with just the two globes connected, just under 200 watts, the sound pressure level is around 40 decibels. I'm now going to increase the load and measure again. Right, and I have close to 500 watts connected. And still we can see that the SPL is below 45 decibels, which means it is within specification. All right, so what do I think of the unit? It says the maximum output is 720 watts. I only tested it up to 600 watts. It did power up all those globes for a short time though, but it did do it. Remember that when it says maximum output, it's not an output that I should be expecting to run for a long period of time. So that just means that if your device needs a quick boost, it's there. With regards to the output voltage, it's pretty stable. I noticed that even when the battery had depleted somewhat, it was still pretty good in terms of maintaining that output voltage. So yes, it does maintain the voltage regulation. The output waveform is a PWM. It would be nice if it was a modified sine wave. The output frequency was spot on at 50 Hertz. The backup time said 33 minutes at 200 watts. I got a bit less than that. I ran that test twice and it was about half an hour. It's not a bad result, but what's more important is that because it's lithium, after several times of running the unit to complete discharge, I should expect to still get about that 30 minutes even after a couple of weeks. And that for me is the purpose of purchasing this type of unit because of the lithium polymer battery. The noise level is definitely less than 45 dBs even when loaded. The built-in USB charger works. I was able to charge my phone at 5 volts. Yes, it does have the automatic voltage regulation. It does say it's got a built-in circuit breaker, although the circuit breaker never operated, but I did notice that it did cut out the unit if I tried to overload it with that iron, both in the backup mode when it was running from batteries as well as when it was running from mains. It claims to have a high quality lithium polymer battery. I cannot verify that until I've used this for many months to determine if indeed it is a high quality battery. The unit does have a bit of a buzzing sound when it is operating. Not terrible. It does get louder if you increase the load. It does not have an alarm or buzzer. That is quite a nice thing if it's going to be next to your table during load shedding or a power outage. You don't have to have that doot all the time, so that is nice. It doesn't have a fan, and I did notice that it does get quite warm, but nothing to worry about because it does have an internal thermal cutout. I did take a measurement and I noticed that the transformer does get pretty warm. The transformer probably should be a bit bigger. It's still pretty warm even now, But then again, looking at the size of the unit, it is not designed to be run at 80% load. Its happy place is about 200 watts or less, and then it will run stably. If I increase that, it does get pretty warm. Comparing it to other types of UPS in the market, I'm not knocking the brand. I'm just saying that this is a lead acid type UPS, meaning inside the unit are these types of lead acid batteries. Now, while this is a very good quality battery, it just cannot compete with a lithium ion battery. In terms of lifespan, I've had so many of these lead acid battery UPSs, and frankly, it's actually just a waste of money in my opinion. Now, at the time, there weren't such things available, and hopefully other manufacturers will slowly migrate so that the users can have a longer lifespan with their UPSs, because I've spent many hours changing these lead acid batteries to resurrect these UPSs, which don't last even a couple of weeks with the South African load shedding. So if you just need a backup system that can give you 10 or so minutes quickly to save your work and shut down for a very occasional power outage, maybe once a month or something like that, then yes, a lead acid system can work. But unfortunately in South Africa, we've got this persistent load shedding, and if you are someone who's going to want to have the backup power there every day, then you're going to need to use a lithium battery, and this UPS does have it. Unfortunately, I have not used this for very long, so I'll have to come back and do a follow-up review to say whether these lithium batteries are giving me the 800 cycles or 2000 cycles. Unfortunately, it's not stated in the manual how many cycles I should expect, but just by the nature of lithium batteries, they already last longer than lead acid batteries. It does take quite a bit of time to recharge the unit. So overall, I think this is a good idea to go lithium on a UPS, and thanks for watching, and cheers.